Imagine capturing the intense leftover heat of a nuclear reactor and using it to generate a fuel that produces zero carbon emissions. For decades, scientists globally have pursued this concept in university labs and small-scale experiments, but the engineering required to make it work at a national level remained out of reach. That changed yesterday. India has officially commissioned the world's very first commercial-scale nuclear process heat-based hydrogen facility, right on the coast of Tamil Nadu. The facility at Kalpakkam utilizes ultra-high-temperature thermal energy to split water molecules apart, creating a massive, steady flow of pure hydrogen fuel. This breakthrough is an immediate practical victory for regular citizens, providing the foundation for a new energy economy that will lower the future cost of transportation and groceries. To understand the scale of this achievement, we have to look at how hydrogen works. It's an incredibly powerful fuel, and when you burn it, the only byproduct is pure water vapor, no toxic chemicals and no smoke. However, pure hydrogen doesn't exist naturally on Earth. It is almost always chemically bonded to other elements, most commonly with oxygen to form water. Think of a water molecule like a set of Lego bricks, where the hydrogen is tightly snapped onto the oxygen. To tear them apart and get the fuel you need, you have to apply a massive amount of physical energy. Today, 95% of the world's hydrogen is produced by burning natural gas and coal to create that energy. This creates a paradox. The final fuel is clean, but the factory making it releases a catastrophic amount of carbon dioxide into the sky. While we can use solar or wind power to split these molecules through electrolysis, the process requires such a massive amount of electricity that the final fuel becomes too expensive to use at a national scale. Hydrogen can only become a true clean energy solution if we find a way to break those molecular bonds without relying on fossil fuels or expensive electricity grids. Traditional nuclear plants are often forced to be wasteful. They create intense thermal heat to spin a turbine, but they eventually have to vent the leftover steam out into the atmosphere as waste heat. Indian engineers at the Indira Gandhi Center for Atomic Research designed a way to capture that 800-degree waste steam and pipe it directly into a neighboring hydrogen factory. This relies on a core principle of physics. When water is superheated into an ultra-high temperature vapor, the chemical bonds holding the atoms together become loose and fragile. Because the water is already vibrating with nuclear heat, it is much easier to break. This is high-temperature steam electrolysis. Since the heat does 90% of the heavy lifting, the facility only needs a minimal electrical spark to finish the extraction. The electricity required drops by more than 35%. To keep the process safe, the team engineered a multi-layered isolation loop. The water being split never physically touches the reactor core. Instead, the heat is transferred through ceramic exchangers using inert gases to ensure no radiation ever enters the fuel supply. By slashing the electricity consumption through sheer physics, India can now produce pure, zero-emission hydrogen at a commercial cost that was previously considered impossible. The economic impact of this is immediate. India currently imports more than 80% of its crude oil, which leaves our national economy vulnerable to global supply shocks and price spikes in the Middle East. Massive supplies of affordable domestic hydrogen can replace diesel in our heavy transportation sector, powering long-distance commercial trucks, cargo ships, and interstate buses. This transition directly targets the source of urban air pollution by replacing toxic tailpipe emissions with pure water vapor, helping to lift the heavy smog that sits over our most crowded cities. This technology also transforms our food supply. Hydrogen is a foundational raw ingredient used to manufacture chemical fertilizers for our farms. Currently, India relies on expensive, fossil fuel-based hydrogen to produce these fertilizers. Using ultra-cheap nuclear-heated hydrogen locally will drive down fertilizer costs for our rural communities. Producing this fuel domestically insulates the entire country from global inflation, ensuring that both the food in your kitchen and your daily commute remain affordable and stable. By commissioning this facility, India has moved into a leadership position as a global exporter of advanced clean energy technology, outpacing many Western and East Asian nations. This industrial shift is expected to create a wave of high-value jobs in engineering, manufacturing, and data science for the next generation of workers. The achievement at Kalpakkam proves that we can repurpose industrial waste heat into the most powerful clean fuel on Earth. Mastering this physics-driven production process provides India with a clear path toward total energy independence and long-term financial stability. As we build out this new infrastructure, do you think India should prioritize hydrogen for heavy transport, or should we continue to focus mainly on battery electric vehicles? Let me know your thoughts in the comments, and I'll see you in the next video.